Mercury, the planet closest to the Sun. Hello, everyone. Welcome to Space Explorer channel. Mercury is the closest planet to the Sun and the smallest of the 8 planets in the solar system. It's an intriguing world with a difficult environment due to its close proximity to the Sun. Despite its inhospitable conditions, Mercury is still a fascinating planet to explore, and it holds many secrets that have yet to be discovered. In this video, we'll be exploring some of the interesting facts about Mercury, such as its size, composition, and its atmosphere. So watch on to learn more about this mysterious planet. Welcome to our video about the planets. Today, we're focusing on Mercury, the closest planet to the Sun. Often called the winged messenger of the gods, Mercury is a fascinating and mysterious world. With temperatures that range from a scorching 800 degrees Fahrenheit in the day to minus 300 degrees Fahrenheit at night, Mercury has some of the most extreme temperatures in our solar system. This small planet is also filled with craters, ridges, and cliffs, making it a truly unique and awe-inspiring celestial body. Let's explore this incredible planet and learn more about its many mysteries. Before moving forward, if you are new to our channel, please don't forget to like and subscribe our channel for future interesting videos. Mercury's distance from the Sun. When it comes to proximity to the Sun, no planet can compete with Mercury. Located a mere 36 million miles away from our star, it is the closest planet to the Sun in our solar system. To put that into perspective, the average distance between the Earth and the Sun is around 93 million miles. This means that Mercury is about 2.5 times closer to the Sun than we are. The close proximity to the Sun has a profound impact on the conditions experienced on Mercury. As you can imagine, it gets incredibly hot on this planet. In fact, Mercury experiences some of the highest temperatures in our solar system. During the day, when it is facing the Sun, the surface temperature can soar to a scorching 800 degrees Fahrenheit, 430 degrees Celsius. That's hot enough to melt lead. However, despite the blistering heat, the nights on Mercury are frigid, with temperatures dropping to as low as minus 290 degrees Fahrenheit, minus 180 degrees Celsius. The close proximity to the Sun also affects the length of Mercury's year. Since it is closer to the Sun, it takes Mercury only 88 Earth days to complete one orbit around it. This makes a year on Mercury significantly shorter than a year on Earth. While we are celebrating New Year's Eve and making resolutions, Mercury is already well into the first month of its new year. Due to its close proximity to the Sun, Mercury also experiences some interesting gravitational effects. The intense gravitational pull from the Sun actually distorts the planet's shape, making it slightly oval instead of perfectly spherical. This phenomenon is known as tidal elongation, and it causes Mercury to bulge slightly at its equator. It's like squeezing a rubber ball in your hands, causing it to become elongated at the center. The close proximity to the Sun also affects the visibility of Mercury from Earth. Since it is so close to the Sun, Mercury is often lost in its glare and can only be observed for short periods. This makes it a challenging planet to study and observe from our vantage point on Earth. However, during certain times when Mercury's orbit aligns just right with Earth's, it can be visible low on the horizon just after sunset or before sunrise. Mercury's close distance to the Sun has shaped its unique characteristics, making it a captivating planet to study. Its extreme temperatures, short years, and gravitational effects are just a few of the fascinating aspects of this closest neighbor to the Sun. So next time you gaze up at the night sky, take a moment to appreciate the fiery beauty of Mercury, the planet that orbits closest to our celestial heat source. Its unique characteristics and close proximity to the Sun make it a fascinating subject of study for scientists and astronomers alike. By studying Mercury, we can gain a deeper understanding of planetary formation, solar radiation, and the effects of extreme temperatures. The data collected from missions, such as NASA's Messenger spacecraft has provided valuable insights into the composition and geology of Mercury's surface. With ongoing advancements in technology, we continue to unravel the mysteries of this enigmatic planet. From its scorching hot days to its icy cold nights, Mercury reminds us of the vast diversity and wonder that exists within our solar system. So, the next time you spot a twinkling star in the night sky, remember that it could be Mercury, shining brightly as our closest neighbor to the Sun. Mercury's unique characteristics. Mercury, the planet closest to the Sun, is not only known for its scorching temperatures and short years, but also for its unique characteristics that set it apart from the other planets in our solar system. From its iron-rich core to its lack of atmosphere, here are some of the most intriguing and distinctive features of Mercury. One of the most notable characteristics of Mercury is its size. With a diameter of only 3,032 miles, 4,879 kilometers, it is the smallest planet in our solar system. To put this into perspective, Mercury is just slightly larger than Earth's moon. Its small size contributes to its overall density, making it one of the densest planets in the solar system. Another remarkable feature of Mercury is its composition. Like the Earth, Mercury has a core, mantle, and crust. However, its core takes up a much larger proportion of its total volume. In fact, Mercury's core is so massive that it makes up about 85% of the planet's radius. This core is made primarily of iron and is thought to generate a magnetic field, although it is much weaker than Earth's magnetic field. One of the most unique characteristics of Mercury is its lack of a substantial atmosphere. Unlike other planets such as Earth or Mars, Mercury's thin atmosphere is practically non-existent. It is composed mainly of particles blown in from the solar wind and atoms blasted off its surface by the sun's radiation. As a result, the surface of Mercury is exposed to the harsh conditions of space, including extreme temperature variations and bombardment by solar particles. Due to its lack of a significant atmosphere, Mercury also lacks weather systems like we experience on Earth. There are no clouds, storms, or atmospheric phenomena to observe. The absence of an atmosphere also means that Mercury has no protection from the sun's radiation and solar winds. This makes it a challenging environment for any potential future human exploration. One fascinating characteristic of Mercury is its unusual rotation. Unlike most planets, which have a rotation axis that is nearly perpendicular to their orbit around the Sun, Mercury has a significant axial tilt of just over 2 degrees. This means that as it orbits the Sun, its axis of rotation shifts slightly, causing the Sun to appear to move back and forth in the sky from certain parts of the planet. This phenomenon, known as libration, creates unique lighting conditions on Mercury's surface. These are just a few of the unique characteristics that make Mercury such an intriguing planet to study. Its small size, iron-rich core, lack of atmosphere, and unusual rotation all contribute to its distinct identity in our solar system. Despite its challenges, exploring and uncovering the secrets of Mercury is an exciting endeavor that could provide valuable insights into the formation and evolution of our own planet and the solar system as a whole. Additionally, studying Mercury can help scientists better understand the conditions of extreme heat and radiation that exist near the Sun. This knowledge could be crucial for future space exploration missions and the development of technologies that can withstand such harsh environments. Furthermore, Mercury's unique characteristics could also shed light on the early history of our solar system and the processes that shape the planets. By studying the planet's core, scientists may gain insights into how terrestrial planets form and evolve. They can also learn more about the magnetic fields and their effects on planetary bodies. The lack of a substantial atmosphere on Mercury makes it an ideal place to study the impact of solar winds and radiation on a planet's surface. Additionally, the unique lighting conditions caused by Mercury's axial tilt provide scientists with an opportunity to study how sunlight interacts with different surface features. Overall, the study of Mercury's unique characteristics holds the potential for significant discoveries and a deeper understanding of our solar system's history and dynamics. The atmosphere and climate of Mercury. Mercury, the planet closest to the Sun, has a fascinating atmosphere and climate that sets it apart from other planets in our solar system. Despite its proximity to the Sun, Mercury has a thin and tenuous atmosphere that is practically non-existent. This lack of a substantial atmosphere has significant implications for the planet's climate and conditions. Unlike Earth, which has a thick atmosphere that moderates temperature extremes, Mercury's thin atmosphere provides little protection from the Sun's radiation and solar winds. As a result, the planet experiences extreme temperature variations, with scorching hot temperatures during the day and frigid cold temperatures at night. During the day, when the Sun is facing Mercury, the surface temperature can reach up to a blistering 800 degrees Fahrenheit, 430 degrees Celsius, which is hot enough to melt lead. However, during the night, when Mercury is facing away from the Sun, temperatures can plummet to as low as -290 degrees Fahrenheit, -180 degrees Celsius. The lack of an atmosphere also means that Mercury does not experience weather systems like we do on Earth. There are no clouds, storms, or atmospheric phenomena to observe. Instead, the surface of Mercury is bombarded by solar particles and subject to constant exposure to the harsh conditions of space. This makes it an inhospitable environment for any potential future human exploration. Another interesting aspect of Mercury's atmosphere is its composition. It is primarily made up of particles blown in from the solar wind and atoms blasted off its surface by the Sun's radiation. These particles create a thin envelope of gas around the planet, but it is not substantial enough to create any significant pressure or weather patterns. The thin atmosphere of Mercury also has implications for its ability to retain heat. Unlike Earth, which has a greenhouse effect caused by its atmosphere trapping heat from the Sun, Mercury's thin atmosphere does not effectively trap heat. This means that any heat absorbed during the day quickly dissipates into space, contributing to the extreme temperature differences between day and night. Overall, the atmosphere and climate of Mercury are harsh and inhospitable. Its thin atmosphere provides little protection from the Sun's radiation and solar winds, leading to extreme temperature variations and a lack of weather systems. The planet's unique conditions make it a challenging environment for exploration, but studying Mercury provides valuable insights into the dynamics and processes that shape planetary atmospheres. By unraveling the mysteries of Mercury, scientists can gain a deeper understanding of how atmospheres evolve and interact with their parent stars. Surface features and exploration of Mercury. Mercury, the planet closest to the Sun, is a world of wonder when it comes to its surface features and the exploration that has taken place there. Despite its inhospitable conditions, scientists have managed to gather fascinating information about this mysterious planet. One of the most prominent features of Mercury's surface is its countless craters. These craters are the result of meteorite impacts over billions of years. Due to the lack of any substantial atmosphere to burn up or deflect incoming space rocks, Mercury's surface is bombarded by countless impacts. The craters on Mercury can range in size from small indentations to enormous basins hundreds of kilometers wide. These craters provide valuable information about the history of the solar system and the frequency of impact events. In addition to craters, Mercury also boasts impressive cliffs and scarps. These geological formations, known as rises or lobate scarps, are the result of tectonic activity on the planet. As the planet cooled and shrank over time, the crust fractured and folded, creating these unique features. Some of these cliffs can stretch for hundreds of kilometers and reach heights of several kilometers. These scarps provide valuable insight into the geological processes that have shaped the planet's surface. Another fascinating feature of Mercury's surface is its smooth plains, also known as mare or basin deposits. These flat regions cover vast areas of the planet's surface and are thought to be the result of volcanic activity in the planet's past. The smooth plains are made up of hardened lava flows that fill in impact basins, creating a relatively smooth surface. Studying these volcanic deposits can provide insights into the planet's geological history and the processes that shaped its surface. Exploring Mercury has been a challenging task due to its extreme temperatures, lack of atmosphere, and proximity to the Sun. However, scientists have managed to send multiple spacecraft to gather valuable data about this intriguing planet. The first mission to Mercury, Mariner 10, conducted multiple flybys in the 1970s and provided the first close-up images of the planet's surface. Then, in 2011, NASA's Messenger spacecraft entered orbit around Mercury, becoming the first mission to study the planet from orbit. Messenger collected detailed data about Mercury's surface, magnetic field, and composition, revolutionizing our understanding of the planet. In addition to past missions, there are plans for future exploration of Mercury. The European Space Agency, ESA, is set to launch the Bepi-Colombo mission in 2022. Bepi-Colombo is a joint mission with the Japan Aerospace Exploration Agency, JAXA, and aims to further study the planet's surface, magnetic field, and tenuous atmosphere. This mission will provide even more detailed information about Mercury and help uncover more of its secrets. The exploration of Mercury's surface has provided valuable insights into the planet's history and formation. By studying its craters, cliffs, and plains, scientists can piece together the puzzle of how this mysterious planet came to be. The past and future missions to Mercury continue to shed light on its unique characteristics and the processes that shape rocky planets in our solar system. These missions have also revealed fascinating discoveries about the planet's magnetic field. Scientists have found that Mercury has a surprisingly strong and complex magnetic field, despite its small size. This magnetic field is believed to be generated by a combination of the planet's metallic core and its slow rotation. Understanding the dynamics of Mercury's magnetic field can provide valuable insights into the internal structure and composition of the planet. Furthermore, the exploration of Mercury's surface has raised intriguing questions about the planet's formation. Scientists have discovered that the surface of Mercury contains elements and minerals that are unexpected for a planet so close to the Sun. These findings suggest that Mercury may have formed in a different region of the solar system and migrated closer to the Sun over time. Investigating the origins of Mercury can provide valuable clues about the early evolution of our solar system. Myths and misconceptions about Mercury. Mercury, the planet closest to the Sun, has long been a subject of intrigue and mystery. As with any celestial body, it has its fair share of myths and misconceptions that have persisted over time. In this section, we will explore some of the common myths and misconceptions about Mercury and shed light on the truth behind them. One of the most common misconceptions about Mercury is that it is the hottest planet in our solar system. While it is true that Mercury experiences scorching temperatures on its surface, it is not actually the hottest planet. Venus holds that title, with an average surface temperature of around 900 degrees Fahrenheit, 475 degrees Celsius. Despite being closer to the Sun, Mercury's lack of atmosphere means that it does not retain heat as efficiently as Venus, resulting in lower average temperatures. Another myth surrounding Mercury is that it is a lifeless and barren planet, with no potential for sustaining life. While it is true that the extreme conditions on Mercury make it an inhospitable environment for life as we know it, scientists cannot rule out the possibility of microbial life existing in extreme environments. The lack of an atmosphere and intense radiation make it challenging for life to thrive, but future discoveries and advancements in astrobiology may reveal surprises about the potential for life on Mercury. One myth that has persisted about Mercury is that it is always in a state of extreme darkness. This misconception arises from the fact that Mercury has a 3-to-2 spin-orbit resonance, meaning it rotates on its axis 3 times for every 2 orbits around the Sun. This unique rotational pattern results in a phenomenon known as tidal locking, where one side of the planet always faces the Sun. However, this does not mean that the planet is in a constant state of darkness. The side facing away from the Sun experiences nighttime, while the side facing the Sun experiences daytime. There is also a misconception that Mercury is a smooth and featureless planet. In reality, Mercury's surface is filled with numerous craters, cliffs, and plains, as we discussed in the previous section. These features provide valuable insights into the planet's geological history and the processes that have shaped its surface over billions of years. Lastly, there is a myth that Mercury is the least explored planet in our solar system. While it is true that Mercury poses unique challenges for exploration, several missions have been sent to study the planet in detail. The Mariner 10 mission in the 1970s provided the first close-up images of Mercury's surface, and the Messenger spacecraft, which entered orbit around Mercury in 2011, revolutionized our understanding of the planet. Furthermore, the upcoming Bepi Colombo mission, a joint endeavor by the European Space Agency and the Japan Aerospace Exploration Agency, aims to further study Mercury's surface and atmosphere. In conclusion, Mercury, the closest planet to the Sun, has its fair share of myths and misconceptions. While some may believe it is the hottest planet or devoid of any interesting features, the truth is far more fascinating. From its extreme temperatures and unique rotation to its diverse surface features and ongoing exploration, Mercury continues to captivate scientists and researchers. It is a testament to the enduring curiosity and thirst for knowledge about the mysteries of our universe. As technology advances and our understanding deepens, we can only anticipate more revelations about this fascinating planet. Whether it is uncovering clues about the formation of our solar system or searching for signs of life in the most inhospitable environments, the study of Mercury pushes the boundaries of our understanding and inspires us to continue exploring the wonders of the cosmos. So let us set aside the myths and misconceptions and embrace the incredible journey of discovery that Mercury offers us. He's smallest planet in our solar system and nearest to the Sun. Mercury is only slightly larger than Earth's moon. The latest. Check out our new space. From the surface of Mercury, the Sun would appear more than 3 times as large as it does when viewed from Earth, and the sunlight would be as much as 7 times brighter. Despite its proximity to the Sun, Mercury is not the hottest planet in our solar system. That title belongs to nearby Venus, thanks to its dense atmosphere. Because of Mercury's elliptical, egg-shaped orbit and sluggish rotation, the Sun appears to rise briefly, set, and rise again from some parts of the planet's surface. The same thing happens in reverse at sunset. An unusual interior could help to explain the differences in Mercury's magnetic field when compared to Earth. Observations from Messenger revealed that the planet's magnetic field is approximately 3 times stronger in its northern hemisphere than in its southern. Russell co-authored a model that suggests that Mercury's iron core may be turning from liquid to solid at the core's outer boundary rather than the inner. It's like a snowstorm in which the snow formed at the top of the cloud and middle of the cloud, and the bottom of the cloud too, said Russell. Our study of Mercury's magnetic field indicates iron is snowing throughout this fluid that is powering Mercury's magnetic field. The discovery in 2007 by Earth-based radar observations that Mercury's core may still be molten could help explain its magnetism, though the solar wind may play a role in dampening the planet's magnetic field. Although Mercury's magnetic field is just 1% the strength of Earth's, it is very active. The magnetic field in the solar wind, the charged particles streaming off the Sun, periodically touches upon Mercury's field, creating powerful magnetic tornadoes that channel the fast, hot plasma of the solar wind down to the planet's surface. If you enjoyed from this video, please don't forget to like and subscribe our channel for future interesting videos. Thanks for watching.